Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight are three of our students who I will let introduce themselves and say hello, and we will start off with Brayden.
Hello, my name is Braden. I'm a music ed student here at UMD.
Hi, I'm Eli. I'm a physics and astronomy student here at UMD.
Hi, I'm Luis. I'm a chemical engineering student at UMD.
So, tonight's show is, I would say, a personal favorite topic to talk about, and we always get questions about this. And so it's kind of a next step after the show we did last week, which was looking at exoplanets, how we find planets around other stars. And so tonight we're going to be talking about aliens and whether any of those exoplanets that we discussed could possibly have life and how exactly we go about searching for that. Now, as I get everything set up for the show, as always, if you have any questions throughout the show tonight, you can leave them down in the comments. Eli will keep an eye on that for me and let me know as questions come in. And there we go. All right. Oops, let me move that screen out of the way. Okay. So, as I said, tonight's show is all about aliens and whether there is life out there. So, when we say the word aliens, these are probably the pictures that come to your mind. If you've seen the movie Alien, you probably think about the xenomorph. Fantastic movie if you haven't seen it. You have the kind of humanoid that's kind of the more gray skin, silver skin, and of course there's always the classic little green man depiction. Well, what I want to start off with tonight is a little bit of background into why some of these classic alien depictions are here, why we have those. Specifically, why we have that little green man depiction. And in a sense, our general fascination for life out there. And it actually starts back all the way in the late 1800s, 1877, when astronomers were looking at Mars. Now, as they were looking at Mars through their telescopes, they started seeing these, what looked like lines etching across the surface. Now, one astronomer, Giovanni Schiaparelli, made a map and he called these markings canali, which is Italian for channel. Now, later, his map got remade, copied, and translated from Italian to English. However, when they did that translation, they made a mistake. Instead of translating canali into channel, they translated it into canal. Now, that might not seem like an important distinction, but there is, because a channel is a natural feature that's just carved by erosion, whereas a canal is a man-made feature. So by calling these things canals, you were inherently implying that there was an intelligent race on Mars creating this canal system of waterways. And that kind of sparked this idea that there was intelligent life on Mars. And from that point on, you started having lots of astronomers making these maps, trying to trace out these canals across the surface. What they ended up deciding was the canals were waterways that were bringing water from the poles down to the equator. And you also had astronomers that were searching for any other evidence that could indicate that there was, in fact, life there. Now, one of the main proponents of this, and one of the people who really got this information out there, was Percival Lowell. He wrote lots of papers, lots of books, gave lots of presentations, and he really helped this become kind of mainstream knowledge that the general public just knew there was life on Mars because we found these canals. It became such a well-known fact that as soon as it was in the general public, it started showing up in in media, so literature, radio shows, all of that. And so that brings us to one author, Edgar Rice Burroughs, who wrote the John Carter series, where you had the Earthman John Carter who was stuck on Mars. And he described the Martians in this series as little green men. And so that's where the kind of origin for that depiction of Martians, which then just kind of became the general depiction of alien, got its start from, was thanks to Edgar Rice Burroughs and the little green men depiction. He also had several other depictions because there were, in his series, he had different races of Martians. So there were lots of different ones, and a lot of them were all kind of humanoid in shape. But that's kind of I say grandfather, that's probably not the right word, but the kind of start of this depiction. Well, unfortunately, you may know this was all incorrect. Back in 1965, we had Mariner 4 fly past, take the first close-up images of Mars, and they showed that there were no canals, no channels, no evidence of an intelligent civilization on Mars. It turns out those markings that astronomers were seeing were really an optical illusion, because our brains are really good at taking random bits of information and connecting them into a pattern. So in 1965, we learned that there was, in fact, not an intelligent race on Mars. But I think that really kind of lit a fire under our curiosity and really wanted us, and really kind of got people thinking that maybe not on Mars, but there definitely probably could be life out there. Even if it's not on our next door neighbor planet, it's out there somewhere. And that's kind of what I think started off the real kind of push for looking for life. Okay, so back to these depictions of what we kind of think about, the stereotypical things when you think aliens. When we are looking for life elsewhere in the universe, this is not necessarily what we're looking for. Yes, it would be fantastic to find another intelligent race, and it could possibly be humanoid in appearance, but that's not the only thing we're looking for. We are looking for any form of life, including microorganisms, single-cell life, bacteria, that sort of thing. All of this is life. And finding anything would be a huge find. So this is included when we're talking about searching for life. This is also in there. And honestly, it's probably more likely that we're going to find kind of simple bacteria or single-celled life first, because, as we're about to get into, that's what lived on Earth for the longest time. So getting into that now, if we are going to look for life somewhere else, we need a kind of understanding of what it takes for life to form. And fortunately and unfortunately, we only have one data point. We have the Earth. And so we want to use the Earth as our case study of how did life develop here, and what can this tell us that we need to search for when looking for life somewhere else. So on Earth, we think life developed pretty quickly. So the Earth is about 4.5 billion years old. We think that life was here by about 4 billion years ago. And we have solid fossil evidence that life was thriving on Earth by 3.5 billion years ago, which is really an important indicator because it tells us that once the conditions are right, life develops pretty quickly, which makes it a lot more likely that life will develop anywhere that conditions allow it to. Now, this very first life that formed here on Earth was deep under the ocean near volcanic vents. And it stayed there for a while before kind of making its way up from being deep in the ocean up to more of like surface levels of the water. Now, the type of life here, again, was that single-celled life, and that stayed around for a very long time. The other thing to know is this life was carbon dioxide based, because at this point in time, the Earth did not have oxygen in its atmosphere. It had carbon dioxide. So the life that developed was carbon dioxide based life. Now, after lots of time, another type of life ended up developing, also carbon dioxide based, but this used photosynthesis. And a byproduct of photosynthesis is oxygen. So it was actually the development of photosynthetic life that led to oxygen building up in our atmosphere. So it is thanks to early single-celled life that we have the oxygen that we humans and lots of other animals depend on. So this built up oxygen in the atmosphere, and then once we had oxygen levels built up, that led to the first oxygen-based life, which was able to get bigger and become more complicated just based off of carbon dioxide-based versus oxygen-based. We're getting deep into biology that I don't fully understand because I'm not a biologist, but just life started to change and develop because of that. And so that's kind of the progression of life here on Earth. And like I said, for the longest time, life was dominated by this simple single-cell and bacterial life. And so because that's been around for the longest time, that's why it's very likely that that's what we're going to find. Larger in life, intelligent life, that seems to take, at least based on Earth, a much, much, much longer time to develop and to get there. Simple life forms very quickly, at least, again, based off of the Earth. So, with that kind of a case study of what's happened here on Earth, we have really just two basic requirements that we think you have to have for life to develop. And that is liquid water, because all forms of life on Earth rely on liquid water. And you need some sort of energy source, whether that is like photosynthesis, where you're getting energy from sunlight, whether it's thermal energy, like those deep, the life that lives deep near volcanic vents, whether it's some sort of chemical source, you have to have some sort of energy source. And so that's your two basic requirements, liquid water and energy. So based off of that, we can now start to search for places that meet those requirements. And it turns out that we have quite a few places in our own solar system that meet those requirements or met those requirements sometime in the past. The first of which is Mars. No, Mars does not have life today, but we have very strong evidence that in the past, Mars was very much Earth-like. It had Earth-like temperatures, it had liquid water all over the surface, it was much warmer than it is today. And so that means during that period of time, when Mars was more Earth-like, this simple life could have developed. And so when we are sending these rovers to Mars, one of the things we're looking for is things like fossils of life that may have been there back when Mars was more Earth-like. There's also the possibility that there could be like lakes of liquid water underneath the surface, and life could have found a way to kind of migrate into those and still be alive in there. Now that's a very hopeful possibility, but it's not impossible. So while Mars does not have those little green men and doesn't have that canal-building intelligent race that we initially thought, it's still a really good place to search for past potential life. Now, speaking of our neighbor planet, a couple years ago, there was some buzz that Venus may actually have life, which sounds absolutely preposterous. Venus is the hottest planet in our solar system. It has temperatures that reach, over 800 degrees Fahrenheit. It stays that temperature all the time, day and night, everywhere, all over the surface. How could life possibly exist? Well, what these studies found was the chemical phosphine in the atmosphere. And phosphine is generally produced by organic life. And so the idea was maybe there is some sort of life living in the upper atmosphere, and it's creating this phosphine, which is why we're reading this. And so there was this buzz that maybe there was actually life in the atmosphere of Venus. Now, unfortunately, probably not the case. Further studies have tried to recreate this finding of phosphine, and they are unable to do so. So it seems likely that that original phosphine reading was actually an error. Which that's what science is, right? You redo and you retest over and over and over again to make sure what you found was what was actually there. So Venus, probably not any life. Mars, quite likely that there was something in the past. Now, what about moons in our solar system? We don't typically think of life developing on a moon, but we actually have a few moons that are very likely to have conditions that could support life. The best candidate is Jupiter's moon Europa, which has underneath its icy crust an ocean of liquid water. You have liquid water. At the bottom of that ocean, we think there is things similar to volcanic vents, which give off thermal heat, which is your energy source. So Europa is kind of the number one candidate for us to look for potential life elsewhere outside of Earth. And when I say that Europa has an ocean, I mean a giant ocean. Europa contains about twice as much water in that ocean than we have on the entirety of the Earth. It's a giant ocean. And that's why we are working to send spacecraft there to actually dive into that ocean and study it and see if we actually do find life, which I really, really want to happen in my lifetime because I want to see alien fish swimming in Europa's ocean. It would be fantastic. Europa is not the only moon to have a subsurface ocean. Saturn's moon Enceladus does. Triton, which is Neptune's largest moon, we think also has some subsurface water. And so there are a few other worlds with similar conditions. These aren't quite as large as Europa's, and they are further away from us, which makes it harder for us to get there. And that's why Europa is kind of the ideal candidate. Now, one more possibility that is not really life as we know it could exist on Saturn's moon Titan. Because Titan, one, has an atmosphere, which is great, but it also has lakes of liquid methane. And just because all life as we know it relies on liquid water, doesn't necessarily mean that there couldn't be a form of life that relies on liquid methane. So Titan is a really interesting candidate for seeing if there could be some other very different type of life that can develop with a different liquid component, with a different liquid need. And so we are very interested in studying Titan for that reason. Okay, so all of the places we've talked about in our solar system, the benefit to them being in our solar system is we can visit them. We can send spacecraft, we can send rovers, In the future, we can send humans. We can go and visit and study. And that means we're not limited to just looking for obvious signs on the surface, but we can look like for Europa and Enceladus. We can look for life that lives under the surface. Now, if we're going to start looking for aliens outside of our solar system, we are much more limited in what we can observe because we can't go to these places. We can't send spacecraft to go study, at least not yet. We are solely reliant on the light that comes to us from these planets. And so when we're looking outside of our solar system, really we're looking for evidence of life on the surface of that world. And that kind of narrows down the possible pool of planets, because in order for life to survive on the surface, there's a few other requirements that you need. You still need liquid water and an energy source. I forgot to add energy source to here. But to survive on the surface, you also need a world that has an atmosphere, because that's going to protect you from the vacuum of space. It's going to protect you from the star. And it's going to provide that carbon dioxide or oxygen or things that life here, at least life that developed on Earth, relied on. It relied on things from the atmosphere. The other thing that is probably very likely to help sustain life on a planet or another world is a magnetic field, which is something Earth has. And the reason this is important is the magnetic field actually helps to help the planet hold on to its atmosphere. Because otherwise, stuff coming from the star can actually strip the atmosphere away from the planet. So we think having this magnetic field helps protect the atmosphere and therefore helps protect life on the surface. So when we're looking at planets outside of our solar system, we are looking for planets that fit these criteria, that they can have liquid water, that they have an atmosphere, and that they have a magnetic field. So based off of that, there are a few very simple checks that we can do to see if a exoplanet fits the requirements for a planet that could possibly sustain life on its surface. So the first thing we want to do is check the temperature of the planet, because we want the temperature to be not too hot or not too cold. If it's too hot, water is not going to be a liquid on the surface, it'll be a water vapor. And if it's too cold, then the water will freeze and it'll be ice. So what we look for is a planet in what's known as the habitable zone, or the Goldilocks zone, where it's the right distance from its star to be the right temperature to have liquid water on its surface and not water vapor and not ice. So we need to check the temperature and make sure that it is just right for liquid water. The other thing we want to take a look at is the size of the planet, because the size of the planet is going to, one, determine if it's a rocky planet like the Earth, or a giant planet like Jupiter, which doesn't have a solid surface. So you can't have surface life because there is no surface. But we also want to make sure that it's not too small, because planets that are very, very small don't have magnetic fields, and they usually don't have an atmosphere because they're not big enough to hold on to that. So we have kind of a range in sizes that we're looking for this potentially habitable planet. Okay, so based off of that, we have, last I checked, about, I think it's 55? Checking, yes. We have 55 planets that we have found around other stars that meet these requirements, that are the right temperature, and that are the right size. These are some of the closest of those. But we have 55 potentially habitable exoplanets. And those are just the confirmed ones. We have hundreds that we are still waiting for further data to confirm whether they meet all of the requirements. So we're going to take a look at a couple of these. First is Kepler 186f. This is a exoplanet that is very close to Earth size. It is Earth temperature, based off of, again, its distance from its star, and so it is a very good candidate for an Earth-like planet. Next we have Proxima Centauri B, which is a particularly exciting, possibly habitable planet because it's orbiting the closest star to us. So it's essentially right next door. So we have a possible Earth-like planet very near to home, which could serve as a really good kind of goalpost for us to expand out of our solar system and start colonizing planets around other stars. We are looking like way in the future at this point, but it's very cool that we have one super close by. And then another one that is included in these potentially habitable worlds, but isn't very Earth-like, is Kepler 22b, which is quite a bit larger than Earth, but we think it could be a giant ocean world. So you could have just a water world, and so you could have, of course, aquatic life on it. So these are just a few of these many habitable or potentially habitable planets that we have found in our solar system, or not in our solar system, oh my gosh, in the universe around the closest stars to us. Now, just because they are potentially habitable doesn't mean that there is actually life there. And of course, as I said, we can't actually travel there to search for life, or at least we can't yet. So how would we know? How would we be able to tell for sure that there is life here, other than just saying it meets the requirements, so it could possibly host life? But of course, we don't know. It just might have the right conditions. Well, this is where looking at spectra can help us. So what happens if the star that the planet is orbiting around, when its light passes through the planet's atmosphere, not all of that light makes it through the atmosphere. Some of it gets blocked, some of it gets absorbed by the different chemicals in the atmosphere. So by the time the light makes it to the Earth, we see that there are missing pieces, that there are missing colors. And by looking at those missing colors, we can figure out what the atmosphere is made of. And by looking at what the atmosphere is made of, we can look for clues that hint at life. And we know what these clues are because we know what Earth's atmosphere looks like. And so that has given us the puzzle pieces of what we want to see in another planet's atmosphere. So we search for things like water vapor, because if there's water vapor and the temperature is correct, that means you probably also have water as a liquid on the surface. We look for oxygen or ozone, because as we saw on Earth, oxygen didn't build up in our atmosphere until photosynthetic plant life developed. So if we see a lot of oxygen in another planet's atmosphere, that could indicate life. We look for things like methane, because again, methane is a byproduct of life. So that could be another indicator. And so that's kind of what we need to look for. We need to be able to analyze the atmospheres of these worlds, and that can help give us clues as to whether or not there very well could be life there. So to end us off, we have focused solely on life existing on another world. So I want to end with a very weird question. Could life exist just in the vacuum of space? Does it have to have a world to live on? And the kind of knee-jerk answer that everyone has is, well, no, obviously not. You can't have life just floating around in space. Turns out there is a form of life here on Earth that can survive the vacuum of space. And that's these cute little guys, the tardigrades. So maybe we shouldn't restrict ourselves to just looking at planets, although looking at the vacuum of space just for life is absurd. But it's kind of really cool that we do know of some species that could survive if they got blasted into space. All right, so that's kind of our look at life elsewhere in the universe, what we're kind of search for when we look for that, and the possible places that we are looking. Now, I haven't actually answered the question, could there be life out there? My honest opinion is yes, obviously. We have found 55 potentially habitable worlds in the little bit of time that we have been studying, looking for these things. There are hundreds more that are likely candidates. And that's all just around the stars closest to us. Based off of what we have found, we estimate that at least 20% of stars in our galaxy have an Earth-like planet. Our galaxy has 200 billion stars. 20% of that is a lot, billions and billions of Earth-like planets in our galaxy alone. Our galaxy is one of about 2 trillion galaxies in our universe. So based off of statistics alone, yeah, pretty sure that there is life out there. Now, whether or not we're ever going to see it, whether or not that life is intelligent and that we would ever communicate with it, that is an entirely different question because the universe is big. It takes a lot of time for light and signals to travel. In our own galaxy, if we want to send a signal to the other side of our galaxy, that's going to take 100,000 light years. 100,000 years, sorry, time. So there could be other things out there. There just hasn't been time enough for their signal to reach us. And by the time it does reach the Earth, for all we know, we could be gone. I mean, humans are trying very hard to destroy themselves and destroy Earth. That's a whole other topic. Anyway, so whether we're still around by the time other signals get to us is a question. There's a lot in there. So is there alien life? Is there other life out there? I definitely think so. Will we ever communicate with it? No idea. And that's, I went a little bit over. That's our alien show. I could talk about this a lot. I absolutely love talking about potential life. What about you guys? What do you think? You team aliens or?
I mean, I feel like alien is like a kind of a loaded word. Because like we think about aliens and it's like, you know, big spindly fingers that are gonna use instruments on you inappropriately.
I mean,
but,
alien just means anything not native to Earth.
right. In that respect, absolutely. I mean, as far as we know, there's not like a wall out there somewhere where everything stops. So it's like if the distribution of planets likely to harbor life in our galaxy is applicable to everywhere else, I mean, I feel like it's kind of impossible. But one of our commenters made a good connection in line with what you were saying, Jessica, that you know, life itself probably common, but you know, intelligent life not so much. I think it's also worth talking about the Drake equation, although I don't know if that's a work of imagination or not.
Well, but that's kind of what the discussion I got to at the end of whether we would actually be able to talk to any sort of life, whether any intelligent life out there, that's kind of what the Drake equation gets into.
Right. And as far as the Drake equation goes, it looks like with what data we have right now, which it's a really like thin, shallow argument for how that equation comes together, but like it if it's to be believed, it says that in any galaxy at any given time, there's probably one civilization capable of intelligent communication. So it's like, are we gonna find them? No, probably not. But are they out there? Maybe.
Yeah.
Sorry, Brayden, I didn't mean to cut you off.
Well, my whole thing about it is like, I mean, the universe is like so just massive that like I guess like how narcissistic do you have to be to think that we are the only case of intelligent life?
Yeah.
But like I do like I think it's out there. I just honestly think that, you know, Earth is like so small and in relative to the vastness of the universe that we just haven't come across it yet. Like that's just it.
Yeah,
It sucks
absolutely.
that light travels at a finite speed, because if it
Mhm.
didn't, we'd be in the money.
If it didn't, we wouldn't be able to
Yeah.
see anything.
Yeah, that's true.
We need super light speed. Like
I mean, Star Wars type stuff. Hey,
exactly.
Oh yeah, there you go.
yeah,
Oh,
where
I didn't change to my alien friend for this show. Hold on.
but yeah, like I don't know. Like I feel like it's probably even foolish or like narcissistic, as Brayden said, to think of it as like we're probably the only intelligent life out there. Because I mean, if it happened here, it could happen somewhere else. We probably won't know if it did, but it's just we can't talk to them.
But that's where even just finding any type of life elsewhere will be huge to show definitively
Yeah.
that yes, it happened elsewhere.
Yeah.
Like whether or not it's intelligent or
Yeah.
not, that doesn't matter.
Yeah.
But
But
Yeah.
and like distance is another thing. Like I feel like with the science right now, it's pretty hard to think that we'll ever like physically make it even like outside of the solar system.
yeah.
Like getting to the next star is just such like a like movies make it look so easy, but it's like the laws of physics want to stop you from doing that. And so it's like, will we ever get to interact with them or you know like meet them? Probably not. Like unless there are some aliens that are really good at hiding on Mars. But yeah, I don't know. It's kind of
Give me a sec.
I don't know. It's kind of like existential crisis motivating.
Yeah.
Motivating. Yeah.
Sorry,
Yeah.
my headphones are dying.
But yeah, I don't know. It's weird. But we've got enough problems down here as it is.
Yeah.
It's more, yeah, at the end of the day, it's more of just like a fun little speculative thing that you can do. It doesn't really matter. It doesn't really affect that much at the end of the day. But it's fun to think about.
Yeah.
And it's really fun to talk about.
Yeah, I love it. And I mean, we get asked about this all the time. So, and it's really fun just to do a show about it. All right. Well, I'm going to do one more call for any questions or comments that anyone has. You can put them down in the comments. And while I give that a minute or two to see if anything comes through, let me tell you what's coming up over the next week. So on Saturday is the next edition in our exploration series. We're going to be looking at space telescopes. And this is 100% an excuse for me to spend almost an entire show talking about James Webb, which is in orbit, by the way. Oh my God. Okay. And then next week, believe it or not, is February. So next week's shows will be our usual beginning of month, where we have What's Up February edition next Wednesday, and our constellation show for next Saturday. All right.
So as far as question goes, there's a lot of discussion going on and interesting discussion going on but questions that we can address. It looks like the only thing was a request for a link to the graphic of potentially habitable planets in the galactic neighborhood.
Ah, yes, I will find that and put a link to it in the video. Or I can just email it to you. I have your email. But I'll also put it in the comments in case anyone else wants it. It's gonna probably be 5-10 minutes after we end for me to look that up and find the source that I got it from.
Yeah.
But yeah, I can absolutely do that. All right. Well, I think we will wrap it up there. So thank you, everyone, for joining us tonight. If you liked that show and want to see more of what we do, we are currently streaming regularly on Wednesdays and Saturdays at 7 p.m. Central. You can also go back and look at all of the past streams that we have done, which has been a lot over the past 2 years. You can find that in the video section of our Facebook page or on our YouTube channel, which is linked in the video description. All right, so thank you again. Have a wonderful rest of your evening, and we hope to see you next time. Bye, everyone.